Okay, guys, welcome to week 7 of investment analysis, and today's topic is fundamental valuation part 2. And before we proceed to the actual course content, let me do a little bit introduction about myself. So I'm Xinyi, and as many of you guys may already know, I'm a PhD student here at the finance department of UTS. And my research interest lies in market microstructure, and I'm actually graduating soon. Now on to the actual course content. So for weekly readings, for this week, the reading material is Free Cash Flow Valuation by the CFA Institute, and it is already uploaded in the folder of week 7. So last week, we learned about how to calculate different types of cash flows, such as free cash flow to the firms and free cash flow to the equity. This week, we will be dealing with the actual valuation models. More specifically, we will be dealing with single-stage models and two-stage models. So last week, we briefly talked about the two-stage model inputs. Let's right now do a review on those inputs first. So two-stage models is characterized by two stages of growth rates. The first stage being where the firms are expanding rapidly and experiencing rather high growth rate. So the first input is just the expected cash flows during those high growth period. And what about the second input? So the second stage of the two-stage model is where the firms enters the mature stage and have growth rates slow down. So the second input correspondingly is just the expected cash flows, like when the growth rate is low. So basically the expected cash flows of the second stage. And the final input is a discount rate, which we learned to calculate in lecture 2. And those major discount rates are WACC, which is the cost of the entire firm's capital, or the required rate calculated by CAPM, which is the cost of equity. In last week's lecture, we learned about 3 types of cash flows that can be utilized in valuation models. So if we are measuring the firm value, we should be using free cash flow to the firm, which is just the cash flow to all claim holders in the firm, and can be calculated as the cash flows from operations after adjusting for the cash paying to the government. So that's why we have EB times 1 minus tax rate, and then adjusting for long-term investment. So the long-term investment is just the net capex, and then adjust for the short-term investment as well. So the short-term investment is measured by change in the non-cash working capital. And for the net capex, we are subtracting depreciation from capital expenditure because the depreciation is just a non-cash expenditure. So after doing all those adjustments, we'll be obtaining the free cash flow to the firm. And on the other hand, if we are measuring equity value, we should be using cash flows that are available just to the equity investors. So those cash flows can either be just the free cash flow to equity FCFE or the dividends. And in last week, we learned that FCFE is just FCFF, subtracting the tax-adjusted interest payment, and then plus the net debt. So it's denoted in this formula here. Also, we know that, so one final thing we need to know about those cash flows is that we need to matching those cash flows with the corresponding discount rates. So for example, when we are dealing with cash flows to the firms, so when we're dealing with FCFF, we should be using WACC, which is cost of the entire firm's capital. And when we are dealing with FCFE, we should be using the cost of equity calculated by the CAPM model. the same is true for the DDM model, where we use dividends and also the CAPM model to calculate the discount rate. Now onto this week's content. So if we categorize the valuation models by their growth rate trajectories, two most common valuation models are the single stage model and the multiple stage model. So we will be talking about those two models calculation in the lecture. And we already discussed like what a two-stage model looks like. And a single stage model is just where you will be having a firm exhibiting stable growth rate from the valuation date and onwards, until infinity. So it grows at a constant rate forever. And for the two-stage model, it initially grows at a high growth rate, and then the high growth rate suddenly decreases and to a low growth rate, and the firm will be growing at the low growth rate forever. Also, the two-stage model is just a special case for the multiple stage model. So for multiple stage model, we can have more than two stages. So for example, let's take a look at this example of firm NEA. So for this firm NEA example, it may, like for stage 1, it may grow rapidly at a growth rate higher than 45%. And in the second stage, which is a transition stage, its growth rate gradually decreases from 45% to 1%. And at the third stage, the growth rate is constant at 1%, and which is like really low. So for this example here, basically the stock has three growth stages. Now let's try to derive the single stage model and the two-stage models. And like in these derivation slides, we focus on the scenario where we are using FCFF. So the same will be like the same formulas will also be true if we are using FCFE to do the valuation. And the only difference is just that we have to replace those discount rates. Right now we are using WACC, right? We need to replace WACC with the cost of equity calculated by CAPM model. So now let's focus on the derivation when we use FCFF. So for the single stage model, let's draw the timeline first. So if we look at the timeline here, in year 1, if we denote the free cash flow to firm as FCFF1, then in year 2, the FCFF2 is just equal to FCFF1 times 1 plus G. And in year 3, the FCFF3 is just equal to FCFF1 times 1 plus G raised to the power of 2. And until, sorry, not really year here, but we should actually call it period 1, period 2, period 3, and period T. And at period T, we have the cash flow being FCFF1 times 1 plus G raised to the power of T minus 1. And after forming the forecasts of those cash flows, another thing we need to do is to discount back those cash flows. So let's for FCFF1, we just discount it back by dividing by 1 plus WACC, and for period T, we just discount back by dividing by 1 plus WACC raised to the power of T. So because we know that for single stage model, the cash flows grow forever, right? So T here is a number that is really close to infinity. And with those discounted values, basically each term of this equation here, each term of this equation here is a discounted value of those cash flows. So if we look at those discounted values, we notice that those discounted values constitute a geometric sequence, with the first term being basically FCFF1 divided by 1 plus WACC, and the proportion between two adjacent terms, for example, the discounted value of year 2 and discounted value of year 1 is just Q equal to 1 plus G divided by 1 plus WACC. And as a result of that, we all know that the summation formula of an infinite geometric sequence, right? It is just that the sum S is equal to A1 divided by 1 minus Q. So what we need to do is just to substitute the A1 and the Q here into this summation formula here. Then we will be able to obtaining basically the sum of all those terms, which is the value of the firm. So by substituting those two into this equation here, we actually find out that the value of those discounted terms is just equal to FCFF1 divided by the difference between WACC and the growth rate G. So that's a derivation of the single stage model. Now let's proceed to the derivation of two-stage model. So again, let's draw the timeline first. So let's assume that this for this certain security, its first stage of high growth rate continues until the end of period N. So it stops at the end of period N, and its second stage actually starts from the end of period N, and the growth rate for the first stage is G, and the growth rate for the second stage is GS, and GS is smaller than G. So the derivation for this model is really straightforward and also intuitive. So let's just consider the scenario where we remove all the first N cash flows. What are we left with? We're actually left with a single stage model, right? If we are only looking at the cash flows from the end of period N to infinity, those cash flows are growing at a constant rate of GS. And so it's really intuitive to just calculate the value of the remaining cash flows at period N by using the formula of the constant growth model. So also because we are also because the stage 2 actually starts at the end of period N, we should actually be using the cash flow at period N plus 1 at the first cash flow, as the first cash flow of the constant growth model. So we can calculate the terminal value of these remaining cash flows at period N as FCFF N plus 1 divided by the difference between WACC and the lower growth rate of GS. So after doing that, basically we now have a value. We have a value of the remaining cash flows of the remaining stage 2 cash flows at period N, and it's denoted as TVN. And what we need to do, like to obtain the final value of the firm at period 0, what we need to do now is that we need to discount back both like the cash flows of the high growth stage and also the cash, not the cash flow, but the terminal value that we just calculated. So one thing I want to emphasize is that the terminal value TVN is at period N, and we have to to calculate the firm value, we have to discount that terminal value at period N back to period 0, and we need to add it with the discounted values of period 1 cash flows. That's basically how we can obtain this formula here. Just to make sure that you guys understand what I'm talking about, let's take a look at a more specific example. So in this example here, let's call this little guy George, and George is contemplating about being a YouTube influencer. So we need to calculate the PV of him being the YouTube influencer. And he is expecting that his cash flows is going to grow rapidly from year 1 to year 5. And after the end of year 5, he expects that his cash flow is going to grow at a lower growth rate. And this lower growth rate will continue forever. The reason that we assume that his cash flows can continue forever might be that his YouTube videos can continue like generating income for his descendants, even if he dies. And what do we need to do to estimate the present value for him in this scenario? So like always, the tricky part is just to estimate the terminal value of the second stage, right? And to estimate the terminal value of the second stage, because our second stage actually starts from the end of year 5. So our first cash flow occurs at the first cash flow for the second stage occurs at year 6. So we need to forecast the cash flow at year 6, and then just plug it into the formula for the constant growth model to calculate the terminal value at year 5. And then all we need to do to calculate the present value of George at year 0 is just to discount back all those cash flows from year 1 to year 5 back to year 0, and also discount back the terminal value to year 0, and then plus all those discounted values. And so another name for the constant growth model is perpetuity growth method. And what if the investment do not continue forever? What do we do to estimate the terminal value from the second stage? So the other method we can resort to is the exit multiple method. So basically you can use the PE ratio or the EBITDA ratio at the time point when you stop the investment to estimate the terminal value, and then you as usual discount back this terminal value and discount back those first stage cash flows, and then add those discounted values together. So we have already talked about the derivation of single stage model and two-stage model when we are using FCFF. Let's take a look at those formulas that we just derived, and also take a look. Let's also take a look at the formulas when we use FCFE to do the valuation. So the difference between the calculation when we use FCFF and FCFE is really just the discount rate we use. So no matter we are facing with single stage model or the multiple stage model, what we need to do is just true. So if we are comparing those two formulas for the single stage model, we find that we're just replacing RE. We're just replacing WACC with RE. And also if we are comparing the multiple stage model, like when we use FCFF and when we use FCFE, again, we're just replacing WACC with RE. So we're just using different discount rates. So the single stage models are really straightforward. So we know that the value of the firm is just equal to FCFF 1. So the free cash flow to firm of period 1 divided by the difference between the discount rate and the growth rate. So for FCFF valuation, the discount rate is WACC. And also if we use FCFE to do the valuation, the value that we calculated is the value of the equity instead of the value of the firm. And also, let's take a closer look at the formulas of this two-stage model. So for the two-stage model, we discount the stage 1 cash flows as usual. Just use the usual formulas. And for the stage 2 cash flows, we are actually using the terminal value TVN to directly replacing those remaining cash flows and discounting back TVN back to period 0. So we just use TVN divided by 1 plus WACC raised to the power of n. So that's when we do the valuation using FCFF. But yeah, of course, if we are doing the valuation using FCFE, the final term here should be the terminal value TVN divided by 1 plus RE raised to the power of n, and RE is calculated using CAPM model. Like in the derivation slides, we already showed that the terminal value TVN of FCFF model is just equal to FCFF n plus 1 divided by the difference between WACC and the second stage growth rate GS. And the similar formula applies for the FCFE calculation. And we are simply replacing the discount rate, again WACC, with RE, the cost of equity calculated by the CAPM model. Now let's proceed to the actual calculation example of two-stage model. So here we have a firm called Alloy Mills, which belongs to the industry of textile industry. And it has a stage 1 of high growth phase, stage 2 of stable growth phase. Let me bring up the Excel sheet I prepared for you guys for this example. So we also know the information that we needed to calculate the free cash flow to firm in year 0. So we know the after-tax EBIT is 100, and we know the capex is 40. By the way, all those amounts are in meals, and the depreciation is just 10. And we have the change in the change in non-cash working capital is 20, and we have the market value of that being 500. Also, the cash is 160, and the number of shares is 90. So before we go back to the slides, let's take a look at how we calculate the free cash flow to firm at year 0, like in the Excel sheet. So as we did in the review slides, we know that the free cash flow to firm in year 0 is just calculated the after-tax EBIT minus the net capex. So net capex is just capex minus depreciation, and then minus the change in non-cash working capital. So we just use cell B4, which is the after-tax EBIT, and then minus the difference between cell B5 and B6, and then minus the change in the non-cash working capital, stated in cell B7. So by inputting this formula here, we have the free cash flow to firm in year 0 being 50. Now let's go back to the slides. So we already calculated the free cash flow to firm at year 0. Of course, we also know the WACC being 10%. Now let's move on to basically determine the present value of stage 1 and present value of stage 2 respectively. So to calculate the present value of stage 1, we utilize the FCFF0 we just calculated in the Excel sheet, which is 50 mils, and then you use it to basically times the times the function of the high growth rate. So to obtain FCFF1, we just use FCFF0 times 1 plus the high growth rate. And for FCFF2, we just use FCFF1 times the 1 plus high growth rate, which is actually equivalent to FCFF0 times 1 plus the high growth rate raised to the power of 2. So the same applies for the remaining cash flows. Also, by the way, for this example, we have the duration of high growth being 5 years. So basically, starting from the end of year 5, we will be having the low growth rate of 5%. Now, let's go back to the Excel sheet to do this calculation over here to determine the present value during high growth rate stage. So now let's take a look at here. So we have already formed the forecast for those cash flows, right? To form those forecasts for year 1, we use FCFF0 times 1 plus cell B13. So this is high growth rate of 10%. And for year 2, we just use the FCFF1 times the 1, so times 1 plus B13. So basically, we just so to do this calculation in the Excel sheet, we just copy this cell over the following cells. So for each cell, it's just the previous term times a 1 plus high growth rate. So after doing those, so as we can see for year 5, it's just the year 4 cash flow times 1 plus cell B13. So after forming those cash flow forecasts, we will be able to calculate the present value of those cash flows from stage 1. So we just use, actually the WACC here should be wrong. Let me check the WACC. Yeah, the WACC is 10%. So I inputted here wrong in the Excel, but it doesn't matter because it won't affect the calculation. So to calculate those discounted values, we just use 50. So for year 1, we just use 55 divided by 1 plus WACC, which is in cell B15, and then raised to the power of like the year that the cash flow occurs. And we just do the same for the remaining years. So for each year, we use the forecasted value divided by 1 plus the WACC raised to like the number that the year that the cash flow occurs. So that's why we take the power of say 22 here for year 2. So it's obvious that for each year, the discounted values are just 50. So the PV here is really easy. So it's just 50 times 5, which is 250. So that's a PV of stage 1. Now, again, let's go back to the slides. Let's go back to the slides first. Let me fix this. Okay. Now, this is stage 1. Now stage 2. So for stage 2, we need to forecast first the free cash flow to firm in year 6. So this is just calculated as FCFF0 times 1 plus high growth rate raised to the power of 5, and then times 1 plus this lower growth rate, which is denoted as G stable growth. So recall in the Excel sheet, we derive that the FCFF5 is basically just 80.5 mils. So the FCFF6 is just FCFF5 times a 1 plus a lower growth rate. So that calculation leads to 84.55 mil. Now, again, let's go back to the Excel sheet to do the calculation of the present value of the stable growth stage. So remember, now we have already derived the free cash flow to the free cash flow to firm in year 6. As we can see here, for year 6, we just take the cash flow of year 5 and then times a 1 plus a lower growth rate, which is in cell. So the lower growth rate is in cell B14. And we just input this forecasted cash flow into the constant growth, the constant growth model formula. So here we do the calculation here. We just use this cell G23 divided by the difference between WACC and the low growth rate. So the difference between WACC and the low growth rate is calculated as the difference between cell B15 and cell B14. And after doing this calculation of the terminal value, we will be able to easily calculate the present value of the second stage. So remember, we said that this terminal value occur at year 5. So what we do is that we discount back this terminal value to year 0 by dividing this terminal value by 1 plus the WACC raised to the power of 5. So that's why we are dividing 1 plus cell B15 and raised to the power of F22. So for this two-stage model, we only need to sum the present value of basically of this first stage, which is 250, and with this present value of the second stage, which is 1050. So that leads us to the value of the market value of the firm. So we calculate the market value of the firm in the Excel sheet using cell B31 plus cell B27. That leads to the market value of the firm being 1,300 mils. So all those amounts are in mils. So one final thing here about today's calculation is that when we are calculating using FCFF, as we said, we naturally reached at the market value of the firm. If we want to derive the market value of equity, we need to use the market value of the firm, subtracting the market value of debt, and then plus cash. So this formula here, it is like a direct, basically it's a direct transformation from the formula of enterprise value. Recall we said that enterprise value is just equal to equity plus debt and then minus cash, right? That's how we derive this formula here. We basically just rearrange terms for the enterprise value formula. And in this question's case, because we know that the market value of firm is 1,300 mils, and we know that debt is 500, and we know cash is 160 mils. We do the calculation. The market value of equity is just equal to 960 mils. And with this information, we actually will be able to calculate the price as well. So the price is just the market value of the equity divided by the number of shares outstanding. So and if we look back, we notice that the number of shares outstanding is 90 mils. So we just use 960 mils divided by 90 mils. This leads to the stock price of 10.67 per share. So that's all of the calculation question. And now finally, we have a note on estimating the future growth rate G. So there are actually 3 common approaches to estimate the growth rates. So one is the historical growth rate. I believe you guys have already encountered this approach during our tutorials, right? We are basically just using those historical growth rates posted by the company's management. But the disadvantage associated with this method is that the past is not necessarily a good indication for the future, right? And also the second approach is a consensus approach, where we can use the estimates from those analysts and simply just using the average of their forecasts. But the thing is, like the thing with financial analysts forecasts is that they usually have optimism bias. Because why is that case? Like the fundamental reason behind the optimism bias of the financial analysts is that they have career concerns. So they may have incentives to maintain positive relationships with the companies that they cover. So as a result of that, as a result of trying to obtaining positive relationship with the companies, they would try to provide like more optimistic forecasts than they should have. Because by providing those optimistic forecasts, they can enhance their reputation, and they can also enhance their access to the information. And that would be like crucial for their career in advancement, right? So that's a consensus approach. The third approach is fundamental approach. Basically, for this approach, you need to determine by yourself, like basically how much the firm is reinvesting and how well the firm is reinvesting, and then you trying to like estimate growth based on those two inputs. But this approach also has a very like obvious disadvantage. So the disadvantage is just that it can be very time consuming, because you have to conduct in-depth analysis of the firm. Yeah, that's all of the content of today. And don't forget that still you have this practice session coming up for week 7. So yeah, don't forget to download the Excel and do the practice yourself before you come to the workshop. Okay, thank you guys. That's the lecture today.